Welcome to my CCNA Connecting Networks. This is the fourth series or fourth section of a four-series video set in the CCNA material. Here we're dealing with Chapter 8, Monitoring the Network. So a big part of this is going to be talking about Syslog and SNMP and NetFlow and things like that. You'll notice that our three main sections are Syslog, Simple Network Management Protocol, and NetFlow. The objectives is to explain how Syslog operates and how they work within the small and medium business. How does SNMP, how does NetFlow, how to configure NetFlow data exports on a router, how to enable syslogging, things like that. Alright, so without further ado, let's go right on in. 8.1 Syslog. Syslog allows us to essentially log everything. The nice thing is, Syslog message destination options can be things like a console, a terminal connection, a Syslog server, a logging buffer. Normally, we want to centralize logs just so that we can maintain them and we can analyze them when necessary, or we can have third-party programs analyze them. We have 8 different levels of our syslogs. This is always really funny because when you go for a CCNP, you need to actually know the syslog message levels and the severity. Emergency is level 0, alert is level 1, critical is level 2, error level 3, warning level 4, notification level 5, informational level 6, and debugging level 7. That way, if you get something that says, we will do levels 0 through 3, what does that mean? That means we're going to deal with things like emergency alerts, criticals, and errors. Anything that's a warning, we're going to ignore. So that's why knowing the levels are that important. Syslog message format normally will have a sequence number, a timestamp, a facility, severity, mnemonic, which is basically just a text string, the message, and a description. Service timestamp is also really important because depending on when the logs come in, understanding the way that the timestamps work is that critical. Also, making sure that valid times are also there are also just as important. So log messages can be timestamped with the source address of the syslog message can be sent. This enhances real-time debugging and management. The service timestamp log date time command entered in global configuration mode should be entered on the device. That turns that service on. In this chapter, it's assumed that the clock has been set and that the service timestamp log date time command has been configured. Again, we are understanding that the clock has been set and is working. The Syslog server provides a relatively user-friendly interface for viewing the Syslog outputs from multiple devices. The default logging, things like console logging or buffer logging, they will have 32 messages logged. And again, at the bottom, that will be the proposed output. Router and switch commands for the Syslog client, logging, the IP address of the Syslog server, the trap, and the source interface. Verifying syslog, it could be as simple as show logging. Simple enough, right? All right, moving on, 8.2 SNMP, or Simple Network Management Protocol. You ever get lots of devices and you're trying to configure all of them? Well, SNMP kind of helps with this. You can have an SNMP manager that will actually set and get commands. It will also receive trap commands to the different agents that you deploy. You deploy an agent on the managed devices, and you will configure the agents with the get and set commands. Those agents will in turn return a trap to the SNMP manager. We have a get request, a get next request, a get bulk request, a get response, or set request. Those are the general commands, and there's the descriptions for each one of them. The more important one is the agent traps. Here is an example of how we'd set this up. A GET request retrieves the values from a MIB variable. GET next request retrieves the instance of the MIB variable. Set request will modify the value of the MIB variable, and then should return a GET response. Contains value of the requested variables, and then the trap will transmit an unsolicited alarm condition if issue happens. There are three main versions, SNMP v1, 2, and 3. 3 is what you really want to be using. It actually provides secure access to devices by authenticating and encrypting packets over the network. No longer can anyone just modify them. And this is off of the RFC 2274 through 2275. Again, this verifies and authenticates the messages from valid sources and the encryption portion to prevent content of a message from being read by unauthorized sources. Community strings are how everything is written. Two major types, read-only or read-write. All right, so let's go ahead and let's talk about a management information base MIB object ID. Here we have the SNMP get, the version, the community, the IP address, and the OID number. And then the return should be the obtained CPU value. So if you've never configured a SNMP, what do? Well, required steps: configure the community string and access level with the appropriate SNMP server community string with the read-only or read-write command. Optional commands will be things like the document location of the devices using the SNMP server location text command. That way you can say kind of where it's at. Another option is document the system contact using the SNMP server contact text command. Again, optional ones restrict SNMP access to the appropriate NMS hosts. Basically, it's a way that we can set ACLs so that we can actually verify. And again, SNMP server community string, the appropriate access list number or the name command. Another option is specify the receipt of the SNMP trap option. Sixth option is enable the traps on SNMP agents with the appropriate SNMP server enable traps command. Verify it by doing a show SNMP or show SNMP community commands. Best practices, best security best practices is secure them with the appropriate ACLs, manage the routers with SNMP and Syslog agents, but again, make sure that you monitor the managed network and you make sure that they're secured to the appropriate ACL. Lastly is NetFlow. NetFlow analyzes traffic flow. That way we can make sure we understand how traffic flowing through the network. And that does mean we'll have to need a NetFlow collector and analyzed software. Most organizations use NetFlow for some or all of its flowing key data collection purposes. Basically, this talks about the efficiency measures for the network resources, accounting and chargeback of the resource utilization, is using the measured information to more effectively plan the network, and it uses information to better structure and customize the set of available applications and services to meet that network's needs. NetFlow technology has several generations that provide more sophistication in defining things like flow than the original NetFlow commands. Things like source and destination ports and IP addresses, layer 3 protocols, TOS marketing, logical interfaces, things like that. How do you configure it? You can actually do it ingress or egress, and you can also do the appropriate IP flow exports to a Syslog server or to a NetFlow collecting server. Verifying could be show IP cache flow, show IP flow interface, show IP flow question mark. NetFlow collectors functions. Basically, there is a filter, an aggregate, and the way that we handle the different configuration and user interactions with this. Here is the NetFlow analyzers with a NetFlow collector. Basically, you start seeing kind of who's doing what packets are being used, so forth. And that's actually the end of this chapter. If you have any questions, please let me know. Thank you.